We always picture AI as this thing that just learns. It gets smarter and smarter, right? But what if that's not exactly how it works? What if learning something new actually comes with a huge hidden cost?
I mean, just think about it. Imagine you spend years, literal years, getting amazing at playing the guitar. Then you decide to learn the piano. And the moment you get good at the piano, poof, all your guitar skills are just gone. It sounds crazy, but this isn't some sci-fi plot. It's a real, massive problem for AI right now.
Yeah, it's got a pretty dramatic name, catastrophic forgetting. And that analogy of the musician, it's perfect. A classical pianist learns jazz, and suddenly they can't even remember how to play Bach. That's exactly what can happen inside an AI's brain. So today, we're going to play detective. We're going to unravel this mystery of the AI that forgot.
All right, so to crack this case, our first clue is to look at how these AIs actually learn. How are they trained? Well, it basically boils down to two main approaches, two different teaching styles, if you will.
Okay, so first up, we've got something called supervised fine-tuning, or SFT for short. The best way to think about this is like cramming for a final exam. You've got the textbook, you've got the answer key, and you just drill until you've memorized everything. Then there's the other method, reinforcement learning, or RL. This one is way more like learning to ride a bike. There's no textbook. You just get on, you try, you probably fall a few times, but you learn from your mistakes. You get a reward for staying upright, and eventually, you figure it out. So, here's the million-dollar question. Which one of these teaching methods is better at avoiding that whole catastrophic forgetting thing? Well, researchers were wondering the same thing, so they ran some tests. And what they found is pretty wild. Let's look at the data.
Okay, check this out. It's really clear. When they taught the AIs new stuff like math or science problems, both methods were great at learning the new skill. You can see high gain for both. But look at that last column, forgetting old skills. The SFT model, our textbook crammer, had high forgetting. It basically dumped old knowledge to make room for the new stuff. But the RL model, the bike rider, look at that, low forgetting every time. It somehow learned the new tricks while keeping all its old ones.
So what is going on here? This is the core of the mystery, right? They both learn the new task, but one does it by paving over the past and the other builds on top of it. What's RL's secret sauce? How does it manage to remember?
Well, the secret, it turns out, is all about being, well, a little lazy, in a good way. RL has this built-in principle, a kind of secret weapon against forgetting, and it all comes down to one idea, measuring how much you have to change.
Now, the technical term for this is KL divergence, but don't worry about the name. Just think of it as a changeometer. It measures how much the AI has to rearrange its guts, its whole internal strategy to learn something new. A high reading on the meter means a massive, disruptive overhaul. But a low reading, that means it just made a few small, careful tweaks.
And this leads to this really elegant idea the researchers call RL's razor. It's super simple. If there are a bunch of different ways to solve a new problem, RL will always choose the one that requires the smallest change. It takes the path of least resistance. It's not looking for the absolute, mind-blowingly perfect answer. It's looking for a good answer that's closest to what it already knows.
This image really nails the concept. Think of this whole landscape as every possible solution to a problem. SFT, our textbook grammar, is told the perfect answer is on top of that mountain, way over there. So it just teleports. It makes this huge, jarring jump and forgets the path it was on before. But RL, our bike rider, is more like a careful hiker. It's standing in one spot and it just looks around and says, okay, what's the closest, easiest, good spot I can get to from here? It takes a short, efficient walk. No big jumps. And because it doesn't have to leap across the map, it doesn't forget where it came from.
Okay, this is where things get really cool. Because this whole problem, learning new stuff without wrecking your old knowledge, this isn't just a computer science puzzle. Nope, it's a problem that nature itself had to solve eons ago.
Turns out this is a fundamental challenge for any kind of intelligence, including us. And if we look at the most powerful learning machine on the planet, the human brain, we find that it came up with an absolutely brilliant solution.
See, for millions of years, the human brain has been using this incredible two-part system to solve the exact same learning versus forgetting dilemma. It's a theory called complementary learning systems, and it's genius. Here's how it works. You've got two parts. First, the hippocampus. Let's call this your brain's notepad. It's super fast. It scribbles down all the specific stuff from your day, what you had for lunch, that funny thing your friend said.
It's all about capturing new things, right now. But then you've got the neocortex. This is the library. It's huge, it's organized, and it learns slowly. This is where you store the big picture stuff, the deep knowledge, how gravity works, what a cat is. The library is built for long-term stability, not for speed.
So how do the notepad and the library work together? It's like this elegant little dance that happens every single day. Step 1. You live your day, and your hippocampus, the notepad, is furiously taking notes. Step 2. You go to sleep. And this is the magic part. Overnight, your notepad replays those new memories to the big library over and over again. And that brings us to step 3, integration. Because of that replay, the library, your neocortex, has time to slowly and carefully figure out where this new piece of information fits. It's not just shoving a new book on a random shelf, it's finding the perfect spot, making sure it doesn't mess up the whole organizational system. It's a slow, conservative update. And that's how we avoid catastrophic forgetting. So now let's put these two stories together, the AI and the brain. Because when you see them side by side, the connection is just impossible to ignore.
Here it is, the big reveal. That lazy conservative strategy that reinforcement learning uses, the whole path of least resistance thing, that's not just some random quirk of an algorithm. It is a digital echo of what our brains have been doing for millions of years. The brain's slow, careful integration of memories into the neocortex, that is nature's way of finding the solution with the lowest KL divergence. It's the exact same principle. Update what you know with the absolute minimum amount of disruption.
So, let's wrap this all up. What's the bottom line? Well, first, catastrophic forgetting isn't some weird bug in AI. It's a basic challenge for anyone or anything that learns. And second, the solution, whether you're talking about a brain or a computer, seems to be this. Be conservative. Make the smallest change possible. Reinforcement learning naturally does this, which is why it's so good at remembering. It's accidentally copying the brain's own tag team strategy. A quick notepad for new stuff, and a slow, steady library for knowledge that lasts.
And that leaves us with a really big question to chew on. What if the secret to building better, smarter AIs that can learn without forgetting isn't buried in more complex code or bigger computers? What if the answer has been right here, inside our own heads all along? It really makes you think, doesn't it? To build a truly intelligent machine, maybe we first need to make it a little more like us.